Okay, so 4.6, angle, angle, side, angle, and hypotenuse leg for triangle congruence. So I want you to notice here that we have this, okay, and it's a little bit different this time. AB is indeed congruent to DE, so we can see that. I can see that angle A is congruent to angle D, and angle B is congruent to angle E. So I have an angle, and then a side, and then an angle. So if angle A is congruent to angle D, and side AB is congruent to side DE, and angle B is congruent to angle E, okay, then we have angle, side, angle. So triangle ABC is congruent to triangle DEF. All right, so this one, angle, side, angle. Okay. Next, we're going to have, before I do that, the side is between the angles. Now, this is a little different than this one, side, angle, side, where the angle is between the sides. Okay, so this is 4.5, side, angle, side. This one is angle, side, angle. Okay, it's like a little angle sandwich. Got an angle and you got the side in between. Okay, now this one here, angle, angle, side. I'm just going to tell you right now, there is no side, side, angle. There isn't. It doesn't work, and we can have a whole lesson for you on why it doesn't work, but for right now, just understand that there is no side, side, angle. Okay? Now, here we go. Angle, angle, side. Well, I can see right here that B, C, and EF are congruent. I can see that B and E are congruent. And I can see that A and D are congruent. Okay, so let's go ahead and start making our points of note over here. So angle A is congruent to angle D. Then angle B is congruent to angle E, and then we have our side. BC is congruent to EF. Okay, so because I have this happening, and by the way, the side is opposite the angles. Basically, I have two angles in a row. Okay, so I have an angle and a side. Okay, we can even label it angle, angle, side. So because the side is on the end and it's opposite, like what we mean by opposite is it's not next to, not in between, so it's opposite the angles, then we know that triangle ABC is congruent to triangle DEF. Okay? Sounds good. Now, here's another one, and this one is really cool because this is only for right triangles. Okay, so a right triangle has a hypotenuse and two legs, if you'll remember that from Pythagorean theorem, right? So here's what we have. Well, I can see that right angle. It's right there. So I know that this is a right triangle, okay? When that means I'm just looking to see I have one pair of legs and then the hypotenuse. So if the legs are congruent, and then this is the hypotenuse, this one over here is hypotenuse. So if you have both hypotenuse congruent to each other and one pair of legs congruent to each other, then this right triangle, they are congruent. So we have side BC is congruent to side EF, and then leg AB would be congruent to DE. Okay, so as long as that's happening, then triangle ABC is congruent to triangle DEF. Okay, and then here's just a little more information. The hypotenuse is the side opposite of the right angle. You should know that. And the leg is the side adjacent to the right angle. Okay, so let's set this aside and let's take a look here. Okay, I'm only going to do like a couple of these, and then you could go ahead and do them. Let's see. And then we're going to do a couple of proofs. And actually, I'm going to change my mind right here. Okay, your job, I want you to do this on your own. Okay, I want you to do this one on your own, part of your packet, I know, but go ahead and do this part on your own. You need to be able to get this information. You need to be able to process these, because this is the kind of stuff that would show up on a quiz or a test. All right, and we can go over it when I get back, or you can look at it online on Schoology. Let's go ahead and move on to this right here. Okay. All right, so here we go. We have SQ, and it bisects angle RQT. So this right here, this line, SQ, first of all, it's going to be congruent to itself. So I'm going to go ahead and mark that. Now it bisects, that's real important, the angle QR or RQT. So that means that this side and this side are congruent halves. And it also bisects this angle over here. So I'm going to have this half RSQ and this half TSQ. All right? So I've got two pairs of congruent triangles, and I have a side in the middle. So this looks like an angle here, and then a side, and then an angle. And then this is an angle. They match. This is the side, and then these angles match. Okay, so it does look like angle, side, angle, ready to go. So then all of the information that was presented to me is given. All right, got all that. Now, RQS and TQS are congruent. So we're talking about these right here. So RQS and TQS, so those blue ones, they're congruent. They are congruent because of the angle bisector. So this would be definition of angle bisector. And then in that same note, right here, the other two angles, the ones you see over here, those are congruent, and it's the same reason. Definition of angle bisector. Okay? And then QS is congruent to QS. That would be reflexive. So because I have all this information proving this triangle QRS and triangle QTS are congruent by angle, side, angle. Okay? Angle, side, angle. Right? And you can see that right there. All right, moving on to this one. It says that angle BAC is congruent to DEC. So here's BAC. So this angle right here is congruent to DEC. That would be this angle right there. Okay. I can also state, because I know this to be true, it doesn't have to be proven, that this side of angle C is congruent to this side of angle C, because those are vertical angles. Okay. And then it says that C is the midpoint of AE. right here. So that's the midpoint from here to here. And that means that from A to C, that length is the same as C to E. So these are congruent halves. Well, if you look right here, here's an angle and there's the matching angle. Here's a side, there's the matching side, and here's an angle and here's the matching angle. So you can see it looks like angle, side, angle. Okay, let's go ahead and prove that. Now this time we're going to write a lot more for ourselves. We're actually going to write angle BAC is congruent to angle DEC. That's given. Okay, and let's go ahead and write C is the midpoint of AE. All right, we're trying to prove that triangle ABC is congruent to triangle EDC. So that's what we're trying to prove, and we know that it's going to be angle, side, angle. Okay, now normally I wouldn't say to put an answer down here until the end, but we've already done that up here. Okay, so let's talk about this. We have BAC, okay, and then let's see, this will be given. C is the midpoint of AE, that's given. Okay, now midpoint. What does a midpoint do? It creates two congruent halves. So the midpoint is going to cause the next thing to happen. So I can say that AC is congruent to EC. Okay, AC is congruent to EC, and that would be definition of midpoint. Okay. So part number 2 creates part number 3. 1 and 2 were given, 2 creates 3. This number 4 right here isn't anything other than our vertical angles. That's the only other thing that we can talk about. Okay, so we can talk about angle C. Actually, let's do it this way. BCA, so B and C and A, is congruent to angle DCE, and that would be vertical angles. All right, so vertical angles, and that's why I can say that these are congruent. That's this row right here. This is another thing that I like to do, is I like to highlight sometimes when I'm making sure that I have everything down. So I have right here these two angles. It's written right here, and I have a reason that is correct. And then I have C is the midpoint of AE, so that means that from here to here, right? So I have all that. C is the midpoint of AE. That is also given. And then I know that AC is congruent by definition of midpoint to EC. And then finally we have our angle, side, angle, and that's what we proved. Okay, so let's move on. This is going to be angle, angle, side. Okay, here we go. It says that YZ bisects angle WYX. So here's W, here's Y, here's X, YZ. Now YZ is going to be congruent to itself by reflexive. Okay, so then we're going to have WYZ, there we go, and then this side over here. Okay, X, Y, Z. So these are going to be congruent angles, all right, because of this bisector. Okay, now it says